We don't need this. We'll turn this on. There we go. Shines in my eyes. All right, so the title of this talk is a little grandiose, I think, but
Clickbait.
Clickbait, yes, exactly. But thank you for coming. One of the things that one of the things that we wanted to do with Rolang was to make sure that it was a useful general purpose programming language. So over time, a number of different things are going to get added to the language. Standard library features like networking and web clients, and crypto is going to be the first one of those. So that'll come out probably around Mercury. More will get added over time. Maybe the DAppHub guys will help us out with that this year, and we'll get some standard library stuff added in. But when we started thinking about how to build a blockchain with Rolang, we had this vision of a general purpose programming language that was running on a blockchain. And one of the things we started thinking about was whether we could use this to build services that look like the web. And that's led to a bunch of architectural decisions that I think are completely unique, right? So we're going to talk today about some of those features and when they're going to come out and how they work, so you guys can understand a little bit better how our chain is going to redefine what it means to run a web service on top of a blockchain. Obviously, the vast majority of applications are going to have they're going to be hybrids between legacy applications with blockchain components. They're going to be meshed together, right? But that doesn't capture everything, and it doesn't sort of capture the essence of the idea of being able to deploy a censorship-resistant service that people can access consistently, that you can sort of pay to guarantee that content is going to be deployed, it's going to stay on the internet, where you wanted it, and that users are going to be able to find it whenever they want. So the main feature that we've got is something that we've sort of been calling the registry, right? Obviously, in Rolang, everything is about names, right, and processes, and they're very interrelated. The registry is the component in the Rolang virtual machine /node that binds names in Rolang to the outside world, right? It makes public names available within the blockchain context, and it allows your smart contracts to interact with things that are on the legacy web, in DNS and so forth. So that's sort of the general idea. Mike, why don't you tell these guys a little bit about how the registry works exactly, and how we're going to go about registering names and then using them inside smart contracts.
Okay. The registry is going to be a blessed contract. That means it will look like user contracts, but it won't be charged for running. Some other examples of blessed contracts include Rev, the Casper contracts for bonding, unbonding, slashing, those sorts of things. The registry, our current design for it, has two main methods. The first one is register. In order to register a public name, it has to fit into one of three formats at the moment. First one is the hash. So we'll have something like, well, all of the public names that are available are of the form row, colon, and then the type of thing it is. So in this case, hash, colon, and then which hash function you're using, say SHA-256, colon, and then wrap around here, the hash itself. So to register a name of this form, you have to prove ownership of this thing. To prove ownership of a hash, you supply a preimage. So usually you'd want to deploy a contract at an address. If you hash your contract, then you already have the preimage of this hash. It is the contract. So you supply the contract as part of the argument to register along with this thing, and you'll also supply, so it will be register hash URN, the contract, let's call this preimage, just to be clear. The write-only name on which people will send messages to your contract, and an acknowledgement channel to tell you that it has all been done. So here you supply this thing as the first parameter, your contract is the second parameter. You supply one of the two polarized names here, the write-only one in this example, because you're deploying a contract, and it will tell you when it's done there. The other operation is lookup, where you supply the URN and an acknowledgement channel, and it will send back this thing on that channel. So that means if I register this contract, I can go back and replace the contract, and it's discovered to have a bug, say. I can go back and replace the contract with a properly functioning one. It allows us to update software. Anyone who has obtained this name, if they want to continue using it, is welcome to. They can continue using the old contract if they choose to, but anyone who uses lookup in order to obtain the contract they want to talk to will get the latest version. Similarly, we have various other possibilities here. It was asked the other night about whether there was versioning possible, and there will be. It'll be another namespace, something like this, but instead it will have versioning information as well. Another example of one of these namespaces, row, pub key, sec p 256, key. So in this namespace, you get to register something if you can prove ownership of the private key. So it'll send out a challenge. You sign it with your private key. It comes back, verifies that the public key you supplied indeed validates it, and then it's essentially the same thing here. You pass in that URN, except instead of preimage, this will be signed message. Haven't worked out yet the challenge response detail. That may come in here and interact with it later. But basically, it's the same thing, that you've got some proof of ownership of this private key. So you can use your Ethereum keys on the Archain network. But the one that's most relevant to the web is row IANA domain. For this one, the challenge is not a preimage or a signed message, but it's put a text block in your DNS record to prove that you have ownership. So we'll send you a challenge, you put that into your DNS record, we verify that, and then you can forward stuff from there. So the registry allows you to extend current ownership of domains as managed by the IANA and put them onto the blockchain. So you can transfer over that whole existing framework onto our chain and continue to interact with it that way. Is that what you had in mind?
Yes. So does this make sense so far? Yeah. Oh,
Question. Please use the mic.
Yeah.
Right up here.
You have to turn it on and then it'll go green.
Wait till it's green. Yeah. There you go.
There it
So
is.
what entity is doing the actual verification of the proofs on these domain registration events? And how is that coordinated?
The registry is essentially an oracle. Nodes that wish to support it may. I think all nodes have to run the registry. Since all of these can be done in parallel, it's not a state-dependent thing. They can all get consensus that they got the same answer. So at the moment, the design is everybody in a particular region does it. Sure.
Yeah, and for DNS, right? So when you run a node, it's when people look up a domain name, it's going to send a lot of DNS queries, right? So there it is. That's what it's going to cost. That's not probably such a big deal in general. DNS queries are pretty cheap, so feels like a reasonable cost to import the entire legacy DNS system into our chain. Be able to support a couple thousand queries whenever somebody does a lookup. So
now, I said that running the registry itself wasn't going to be, didn't cost anything to the deployer of that contract, since the deployer of the contract is our chain. But clients of this contract, people who want to register these things, will be charged for that privilege. So there will be some phlogiston cost in order to run these, so you're not being able to launch a DNS spamming attack via our chain.
What? You can't just put tens of thousands of entries in the registry? Free? Okay, so this probably seems a little abstract, right? And maybe less abstract than some of the other stuff we covered this week, but why does this fundamentally change the way the web works? And the answer to that question is fairly straightforward. These lookups are just like any other kind of role-line expression, right? They can be deployed as transactions that you send to the node, right? They can be included in role-line code that you ask the node to evaluate on your behalf, right? And so one of the things that you're going to be able to do when you interact with our chain is you're going to be able to write smart contracts that know who they're talking to. And Mike likes to write that, but obviously I want it to be this, right? Because when you guys want to find our public keys or you want to communicate with services that we build, right? It's our domain. It's not just any arbitrary domain. It's the one where you want to find our services, right? HireFX.net, ourchain.coop, google.com, what have you. This is totally new for the blockchain, right? Like at the moment, everything that runs on the blockchain is using. We've got the Ethereum name service, right? But it's slow and clunky, and it's totally separate from DNS, right? So you can't browse conveniently using the ENS, right? You can't connect to the same services via ENS that you connect to on the web, right? But the registry allows our chain to connect the existing legacy web to the blockchain in a way that allows smart contracts and legacy applications to interact much more fluidly, right? What we're hoping, we would like to see is for people to be able to use this to build all the things that we're currently doing with the web, right? Search indexes, maps, right? Social media, all these applications that are currently controlled by centralized organizations, giant corporations, own these things because they own domain names that we all know how to go to, right? Your smartphone comes pre-cached with a bunch of domain names in its browser, right? It remembers the domain names that you go to, right? And all of those names, right? They constitute territory, and that territory is completely centralized. Whether it's Facebook.com or Google.com or what have you, there's no decentralized control of any of that space. But this gives us the ability to work with that existing system, but also to extend it using the blockchain. Right? So now, we could build applications that interact that bring the legacy web into the blockchain and allow you to build the components that you want, right there in our chain.
We have the ability to create new namespaces just like ENS if we want to, but we can use the other ones that already exist.
Exactly. So the task for you guys, right? The thing that we need the community to do, right, is to go out there and to find all of these use cases, all these applications that you use on a daily basis, that you use to interact with your friends, that you use to keep track of people, to find your way around town, to find your way to dinner, to rate restaurants or businesses, to leave feedback for people, all that kind of stuff. We need you to find those applications, and we need you to use these capabilities to build those on the ArtChain blockchain. We're going to provide the platform and the ability to do this stuff. You guys have to write the apps. So
one of the things that we intend to support, not for Mercury, but later, is this format of URN that is something like Express Paths, where you can fill in variables, match subparts of the URN that you're sending on. In this case, it would pull in the ID and user variables, the process variables that were in scope, and this would broadcast to those. One idea is that that it may not pull in the existing ones, but if it's free, it may broadcast to all of those that match. You can also listen on a name like this, and it will bind these variables in the continuation of the body. So this sort of syntax is something we're hoping to support that will make writing web-like apps easier on the blockchain.
Yeah, in Rolang, everything gets turned into syntax, right?
Yeah.
So this is, for me, this is the feature of the blockchain that really got me interested in building this thing. Right. So it wasn't until I realized that we could do this that I really understood what the power of the blockchain was ultimately going to be, and so it's the piece that gets me most excited, right? The idea that what we can do at the end of the day is to take these giant centralized services and decompose them into smart contracts and redeploy them on thousands of nodes running, from data centers all across the world, running in our living rooms, running wherever we want to put our nodes. These smart contracts are going to be there, and they're going to be able to provide exactly the same services that you're used to interacting with on the web, right there on the blockchain, right? So when you interact later this morning, you're gonna listen to Pavel talk about comms, right? Or he's gonna explain to you a little bit about what we're currently doing and what we're going to be doing in the future in terms of allowing clients to interact with the node, right? So we're going to move to a model where we support natively what the node is going to support is gRPC. We'll also have a JSON interface that you can use to interact with it. That's going to allow you to write queries that talk directly to smart contracts on the blockchain, right? So, Mike, can you talk a little bit about how those queries will get formatted so people can understand what they'll be sending to the node?
Well, once you've registered a contract here, it's just interacting with it like you would any other contract. As far as web content that contains JavaScript and so on, there will have to be some client software that it's sending information that it wants to put back onto the blockchain too. So the web client also has to behave as a blockchain client or talk to something that's a blockchain client that will then put information back onto the web on behalf of the client-side software.
Cool. Maybe can we write an example contract that uses this function at this point?
Sure.
While you're thinking, we'll take a question.
So I'm curious about blessed contracts. Do those exist? Are those going to be in the Genesis block? Can they be deployed at any time? And if so, is it up to the co-op to deploy those? And if so, does that risk decentralization to some extent? I'm sort of curious where those come from.
The blessed contracts that will be deployed are those that are necessary for running the blockchain. So at the moment, they only include Rev, which is necessary to pay for contracts, bonding, unbonding, distribution of funds, which is necessary to pay the runners of pay the miners or validators or whatever you want to call them, and the registry, which is necessary for people to be able to register, to be able to put contracts up that nobody else can intercept. So at the moment, those are the only things that we've got that are necessary for creating the blockchain. Those are the only blessed ones. If there are more blessed ones released in the future, it will be because they are necessary to support some feature of the blockchain that we're releasing. So perhaps Venus will have another one or two. But
and they'll be distributed as part of the software, right? So every node that runs the Scala code will also run the blessed contracts, right? So they'll be distributed. They're not deployed, in the way that other smart contracts are deployed, right? They're just there. Yeah, exactly. Step on up.
So I'm curious why you decided to implement this as a blessed contract as opposed to a user space contract.
In this particular case, we had to resolve the issue that public names are a feature of Erlang from the get-go, right? So if you have a language where names and syntax are bound this tightly together, you just get this as a feature. We were concerned about people writing contracts that bound to names like Hierofx.net or Google.com that weren't actually those people, right? So if we have a mechanism, right, that everybody can use to contact code on the blockchain, and anybody can deploy a contract at one of these names, right, then we felt like we wanted a system to control that so that people could actually, get their domain name on the blockchain without having to buy something they hadn't, right?
Yes, so that makes sense, but you could still do that as a user space contract, right?
Yes, you can do it as user space contract. It was necessary to do it at least once. So the one time that it was necessary to do, we made it a blessed one that doesn't need to be paid for. But beyond that, anyone can deploy exactly the same code, get exactly the same functionality out of it.
So there's some, you need to bootstrap it as a blessed contract at least once because of a bunch of things. So like the pub key one, right? Like you can publish a registry at a public name, but if it's not a blessed contract, I can also publish a registry at that same name that doesn't do the signature checks, right?
So the registry itself couldn't run without the registry. Somebody else could write a registry that intercepts that.
So there's another thing. One of the other things is there is no way for user code to do a DNS lookup. We just can't. So that has to be, pulled out of the system. It's a bootstrapping problem. Without the registry, you can't write a registry because somebody else could write a bogus registry.
So does this trigger a DNS lookup when it's run?
Yeah, it can.
Yeah, when you go to register a name that's IANA, the node is supposed to do a DNS lookup for a specific text record that says, yes, this really is me.
Surely that could trigger some non-determinism.
It has to be eventually consistent.
Don't register it until it's propagated.
So as an attacker, this sounds like a really juicy point of non-determinism.
Okay.
Well, either a majority stake of the validators see the correct DNS entry, and so you get registered, or they don't.
Right. Yeah, so any oracle, right? Anytime that you have nodes that have to observe something about the outside world, you have to guarantee that what they're observing is going to eventually achieve some consistency in the outside world so that they can all measure it and get the same value, right? And until they do, you won't be registered, right? Because they won't achieve consensus on the fact that your text record is there. And then once they do achieve consensus on that, your registration will go through.
Well, yeah, I'm really curious about that choice, just because Ethereum has deployed a DNS oracle, but it's all user space and it is asynchronous. Like, you put up a request and someone else has to verify. It does the DNSSEC verification on chain in the contract. So I was just curious why you didn't choose to do it that way.
I don't think we looked at the Ethereum DNS oracle before we designed it, so we just designed what made sense to us. Yeah.
I don't know if you guys have answered this already, but can you talk about maintaining a light client, or instead of maintaining a phone node you have to connect to operate your smart contracts or your dApp?
Yeah, so in Bitcoin, Ethereum, things like that, right, there's sort of this idea of a light client where you don't have to do nearly as much work as the main node, right? But in our chain, it's sort of not that much cheaper, right? The big difference, the light in Light Client is that you don't have to stake, right? So you still want to see the transactions. You're just not going to stake the Casper protocol, so you're not going to participate in validating. The R-Node software will come with the ability to run in that mode natively. You just don't provide it a staking wallet, and then you won't stake the Casper protocol, and it'll be essentially a Light Client, right? You'll know who the validators are, and it'll connect to them, right? And you'll be able to get all the transaction data that's coming through that particular region or namespace or what have you. But since you're not staked, no one will particularly care about your thoughts on race ordering and that sort of thing. So you can still send transactions through such a node, right? And it can then deliver those transactions to the validators, right? So you can still use it as an endpoint. I guess this is the nice thing about it is you can still use it as an endpoint to access the R-Chain network, right? You don't have to stake a validator in order to access all the services that R-Chain provides.
So here's an example of something. Oh, go ahead. Sorry.
Yeah, do the validators have any incentive to communicate with non-validator nodes besides receiving signed transactions?
Well, in a proof-of-stake network, transaction fees are a big deal. So yes, right? Like they want to receive transactions, and most of the transactions will come from non-validator nodes.
Here's an example of something you could deploy. Notice here it says new hello world and then contract bundle minus of hello world. Usually putting a name inside of a new scopes it so that it can't be seen outside of that. But because we're sending it to the registry here, that makes it available to the outside world. So just going through this, new hello world and ACK. So I'm creating a channel on which an unforgeable channel on which my contract is going to listen. I restrict the contract part to the read-only part. So this contract can read from hello world, but nobody else can. It gets a name and there's a response channel. Given the name, it sends some HTML snippet back on the response channel, and that will be the, maybe we could have a 200 OK, et cetera in there, but that's the basic idea. In parallel with declaring this contract, it registers it. So it grabs the well-known registry name, says, issue me the challenge for this domain. Here it says pyrofex.net. And then tell me when give me something back on this ACK channel in order to prove that that was successful. So it gets back X, which is the token that says, yes, I looked it up and indeed you own this. Actually, there needs to be one more step in there so that I can add their challenge to the DNS. But anyway, I get a token back saying that I passed the test. Then I go back and register this thing, handing it the evidence that I passed the challenge, and supply the bundle plus of Hello World. So this is a write-only name. If anyone goes to look up in the registry pyrofex.net, they get this. So now if they try and listen on that name, nothing will ever come to it. In fact, it'll be a type error. And then there's an acknowledgement channel so that I could continue doing things afterward if I wanted to. But this is the basic flow. Fairly short. All of the information about the server is in this thing, and that can be as large as you want. And at any point, you can redo this challenge registration process to replace the contract that's running there at that public name. Any questions about how this would work?
Does this make sense?
Great.
Cool. All right. Well, that's basically all you need, in my opinion. I guess Mike, there's a piece in here where you actually have to.
Yeah, I skipped a step here. I could go back and work it out for you if you'd like. But
So there's one additional complexity where you have to take a challenge and
yeah,
sort of
so on
put it
this,
on
what
your-
I really should have done is say for challenge from ACK.
Okay. Yeah. All right. I think this is, one of the more powerful features to have natively in Rolang and to have on our chain from the very beginning, obviously. We'd like to see, and obviously us and the Reflective guys and the Pythia folks would love to hear from you if you're interested in writing web applications that use this feature, and deploying them on the blockchain, right? Like that's sort of what we're interested in at the moment. Is figuring out exactly how this is going to work out. But I think that's basically the idea, right? It's pretty simple, pretty short and sweet. So hopefully you guys will find it a lot of fun to work with. We certainly are excited to have designed it into the language from the very beginning. So we're hopeful that it's useful for you guys when you're building your decentralized applications. Do we have any more questions about this? Cool.
Yeah, so here's this thing. The issue challenge will send the challenge to ACK. You get it here. Then we tell the DNS Oracle to put the challenge in the text block for this domain. It tells us when we're done. Then we call registry. We might as well suppose that the challenge remembers that it was for that URN. We supplied the hello world and another acknowledgement channel if we choose to do something else after registering. But
Cool. Right on.
just one or two more
So
lines.
question, is this available in the latest build? If not, when can we start playing
Oh,
with
no,
this?
this is nowhere close to available. We don't have a blockchain yet, so we
No,
can't
but
have a registry contract running on the blockchain.
When as developers can we start playing at this level?
Probably testnet time, late summer.
Yeah.
What's that, Meta?
What's that, Meta? Yeah,
Session after next.
right. Go to Meta's session if you want to know the details of the roadmap. Any other questions? Yeah, Mateusz.
So it's more of a technical detail. Yesterday you were talking about the bundle channels names.
Yes?
So, and now you said that if I create a write-only name, when I try to listen on it, it's gonna be a type error.
Yes.
So I wanted to ask, what does the type error mean? Because if I think about type errors, it's something like a compile time. And if I create...
So given, if we can prove that what you are listening on is a write-only name by seeing syntactically somewhere and then tracing your use of it from that, then we will throw a type error. Otherwise, at runtime, it would be a runtime error, and we haven't worked out the error model at runtime yet.
Yeah, but so if I the contract that's creating the name and makes it write-only, so I'm thinking how on the other side, like the other contract that receives wants to...
Right, so if someone is expecting to get a read-only name from the registry, for example, one reason you would use a read-only name here instead of a write-only name is if you're producing a data feed rather than hosting a contract at that address. So you're constantly writing to that name, and everybody else who's a client will be reading from it. If they're expecting a data feed and they get one of these, then there will be an error. you know, when they try to read, it will cause an error of some kind.
But it's going to be a runtime error.
Yes, runtime error.
That's
Any other questions? All right. So I guess we'll give you about 15 minutes back for Pavel's talk, right? Pavel's next? Okay.
Great, thank
15.
you.